All right, guys, I totally miss you guys today, but I know you guys are going to make me proud. Our lesson today is over prime factorization. And when we talk about prime factorization, what we're doing is we're finding the prime numbers that we multiply together in order to get back to our original number. Remember, we talked about prime numbers on Friday, and we defined a prime number as a whole number that was greater than 1 that has exactly 2 factors. And those 2 factors were 1 and itself. So for example, some prime numbers are 2, 3, 5, 7, 11, 13, and I could keep going, okay? So when we do prime factorization, we're going to build what we call a factor tree. So we're going to start with this first problem right here, the number 24. What I'm going to do is I am going to find 2 factors that I can multiply together in order to make the number 24. They don't necessarily have to be prime numbers. I'm just trying to come up with 2 numbers that if I multiply them together could give me 24. And the first ones that pop into my head are the numbers 2 and 12, because 2 times 12 would give me 24. Now, since this is called prime factorization, I'm trying to break down all of the factors until I have nothing but prime numbers left. Excuse me. So when I look at my, excuse me. When I look at my 2 factors that I have, I see that the number 2 is prime. I can't break it down anymore. It's as small as those factors are going to get. So what I want to do is I want to circle those prime numbers. So 2 is a prime number. I'm going to circle it. 12, though, is a composite number because I can keep breaking 12 down. Now, the first way that pops into my head is I could break down 12 in the number 6 and 2. And you might be thinking, well, Miss Smith, I could have made 24 using 6 and 4, and I could have made 12 using 3 and 4. There's not one correct way to break down a number, but no matter how you break down this number, you should get the same prime factors as someone who broke down that number differently. So if I break down the number 12 into 6 and 2, 2 is a prime number, but I can keep breaking down 6. I can break down 6 into the number 3 and 2. 3 is a prime number and 2 is a prime number. So I have broken down all of my factors until nothing but prime numbers are left. So when I write the prime factorization expression, again, I have all the prime numbers that I'm multiplying together to get the original number. So we start with the smallest factor. So I have 2 times 2 times 2, and then last but not least, times 3. Now, just for fun, I'm going to super quickly break down 24. The other way, I'm going to do 6 and 4, just so we can see that we get the same answer. And sure enough, I have 1, 2, 3 2s, 1, 3. So again, proving it doesn't matter how you break it down. If you break it down correctly, you should end up with the same prime factors. Let's go to the number 120. So first thing I see is that number ends in 0. So I know that it can be divisible by 10. So 10 times 12 would give me 120. Now both of these numbers are composite numbers, so I can break them down even further. 10 can be broken down into 5 times 2. 5 is a prime number. 2 is a prime number. I can break down 12 into 3 and 4. 3 is a prime number. Oh, oh my gosh, I almost made a mistake. 4 is not a prime number. Sorry. I can break down 4 into 2 and 2. Okay, so now I'm going to write that expression. Start with the smallest number, the smallest factor. So I see 1, 2, 3 2s. So it'll be 1, 2, 3. Then times 3 times 5. And that'll get me all the way to 120. Let's go to 75. I see that 75 ends in the number 5, so I know it is divisible by 5. Okay, and I, off the top of my head, I'm going to be really honest, don't know how many times 5 goes into 75, but we can figure it out together. I'm going to just come over here to the side and do 75 divided by 5. So 5 goes into 7 one time. 1 times 5 is 5. When I subtract, I get 2. Bring down the 5. 5 goes into 25 5 times. I'm left with no remainder, so it's 5 times 15. That gives me 75. 5 is a prime number, so I'm going to circle it. 15 can be broken down into the numbers 3 and 5. 3 is a prime number, 5 is a prime number, so I'm complete. So again, for the expression, start with the smallest factor, which would be 3 times 5 times 5. Okay, let's go to 144. So I know that 144 I can break down into 12 and 12. 12 is a composite number, so I can break it down even further into 3 and 4. 3 is a prime number, but 4 is a composite, so I can break it down into 2 and 2. 2 is a prime number, so I'm going to circle both of those. Now I'm going to go a little crazy. I'm going to break down 12 differently. I'm going to break it down into 6 and 2. 2 is a prime number, so I'm going to circle it. 6 can be broken down into 3 and 2. So I've got all my prime numbers. Now, when I write this expression, again, I'm going to start with the smallest factor that I see, which would be 2 times 2 times 2 times 2, because there are 1, 2, 3, 4 2s, times 3 times 3. But what if I told you there was an easier way to write this expression? Because we know about something called exponents. Dun, dun, dun. Exponents are going to help us make this so much simpler because exponents show us repeated multiplication, which is what we're doing. We're just continually multiplying. So instead of writing 2 times 2 times 2 times 2, instead I could write this as 2 to the power of 4. And then times, instead of doing 3 times 3, I could write it as 3 to the power of 2. So 2 to the power of 4 times 3 to the power of 2 will give me 144. Okay, let's move on to 81. I know I can break 81 down into 9 times 9. 9 is a composite number, so I got to break it down further. 9 can be broken down into 3 times 3. 3 is a prime number, so I'm going to circle those both. And again, 9 can be broken down into 3 times 3, so I'm going to circle them both. So I have nothing but 3's left. So again, I could write this as 3 times 3 times 3 times 3, or using my shortcut way with exponents, I could write it as 3 to the power of 4. All right, and last but not least, 108. Okay, so I'm going to be really honest. When I look at 108, I don't see a big factor that jumps out to me right off the bat. 108 is not one of our multiples that we talk about often. It's not one of our common math facts. So I don't really know what two good numbers would create 108. So when you reach a problem like this and you're like, I don't really know what two numbers to start off with. Here's a little Smith Super Secret math hack for you. Always start and check to see if your original number is divisible by 2, 3, 5, or 7. Now, why 2, 3, 5, or 7? Because those are our first 4 prime numbers. So we're going to see if maybe we can weed out a prime number right off the bat. Now, so remember our rules to figure out if it's divisible. 2, it has to be an even number. 3, the sum of the digits have to be divisible by 3. 5, it has to end in a 5 or a 0. I'm going to be honest, we don't have a rule for 7, so we just kind of have to cross our fingers and hope for the best here. But I can cross off 5 off the list because it does not end in a 5 or 0. I know 2 could work because 8 is an even number, so I'm going to start there. So I can see that 2 will go into 10 5 times. It goes into 8 4 times. So that would be 2 times 54. Okay. Again, 2 is a prime number, so I'm going to circle it. I don't know. Oh, I do know 54. Wow, I almost said I didn't know 54. My goodness gracious. 9 times 6 will give me 54. 9 is a composite number, which breaks down into 3 times 3. 6 is a composite number, which breaks down into 3 and 2. Okay, so again, when I go to write my expression, the long way, the expanded way, would be 2 times 2 times 3 times 3 times 3. But using exponents, it would be 2 to the power of 2 times 3 to the power of 3. Ooh, that's satisfying. I like that.